In this figure, we'll look at stress and metabolism. What we mean by this is we're going to look at how physical or emotional stress can result in changes to nutrient partitioning and utilization, both acutely on the left and chronically on the right. Now, stress can be induced acutely through fear, short term, very intense exercise, things like that. And then more chronically through things like fasting or long term emotional stress. And so we're showing you two of the three classic phases. The third is called the exhaustion phase, and that's when we no longer maintain homeostasis and really everything starts to fall apart. So these first two phases are about maintaining or attempting to maintain homeostasis in the face of this stressor. And so in the acute phase, also known as the alarm phase, also known as the fight or flight phase, we are going to rely on autonomic nervous system, specifically sympathetic output of norepinephrine, as well as the adrenal medullary release of largely epinephrine or adrenaline. And these are going to be from the adrenal medulla, these are going to be released into the bloodstream. And our primary goal here is to aid in the ability of our bodies to fight or run, essentially, right? Fight or flight, in response to this acute stressor. And so, what we need to do, in metabolically speaking at least, there are multiple other facets to a stress response. But metabolically, we need to supply energy to our working muscles. And so, what we're going to do is we're going to take our liver glycogen, we're going to break it down, and we're going to release it into the bloodstream, helping to supply these working muscles and other tissues. We're going to take our adipose tissue and we're going to break down those fats and we're going to increase our blood lipid levels, again, helping to maintain nutrient supplies for working cells during this acute response. Now, if our stress is more chronic, we're going to continue with the epinephrine release, but what's going to become dominant is cortisol release. That doesn't come from the adrenal medulla, it comes from the cortex, this outer layer of the adrenal gland. And that cortisol is going to shift us from predominantly glycogen and glucose use more towards the fat use. And so what we're going to do is we're going to much more dramatically increase release of fats from adipose tissue. We're going to break those down. We're going to release glycerol. Got to keep that in mind because that's going to come back in a moment. At the liver, we are going to utilize amino acids that are being released from protein being broken down at muscle, so that we're going to provide the backbones, these amino acid backbones, and here's that glycerol from fat. We're going to provide these backbones for gluconeogenesis. Remember, one form of chronic stress would be fasting. And so our carbohydrate stores, which would only really last us a day during a fasting period, have to be maintained. Well, how do we maintain them if we're not actually eating anything? We maintain them through production, gluconeogenesis, using the precursors generated from fat tissue, the glycerol, or the backbones of the amino acids that we're releasing from our protein. And so those end up in the bloodstream, picked up by the liver, we run gluconeogenesis, and we help to maintain our blood sugar levels while we're in this chronic phase of stress. Now, we don't want to produce sugar that is then going to end up being stored in our muscle cells or our fat cells as fat. In other words, we're kind of like breaking down fat and muscle. We don't want to just sort of rebuild fat and muscle. We're producing this glucose to use for cellular ATP production where we need that glucose, right? We don't need to resupply it to the cells from which it basically came from. And so what we're going to do is we're going to decrease our insulin secretion. Insulin-dependent glucose uptake only occurs right here at fat and muscle tissue through GLUT4 transporter induced by insulin. And so we keep our GLUT4 low. That keeps our blood sugar that we are producing available for the cells that actually need it.